Hey, hello everyone, and thank you for joining us today. Welcome to the webinar Optimizing Development and Overview of Connext Tools. Today we are presenting how RTI Connext tools provide visibility into operational systems, help troubleshooting, application connectivity, and solve complex data integration problems, speeding time to market. I would like to introduce our speakers today. Please join me welcoming the RTI team. Brian Sinis, he will be joining shortly. I think he was here and had some technical issues. Brian is Senior Field Application Engineer. He's right. I was just introducing you, Brian. Senior,
Okay.
Senior Field Application Engineer. He's here, and Ken Brophy, Principal Software Engineer at RTI. My name is Irene Aguilar, and I will be your moderator for today. Just a couple of housekeeping notes before we start. Remember to leave your questions in the dedicated tab, and we will answer them at the end of the presentation. And please take a moment to look at the webinar attachments, where you can find more information about Connext tools. So moving forward, I pass the ball to Brian.
Thank you, Irene. Okay, well, welcome to the webinar. I'm assuming that my audio quality is reasonably good. We had some technical issues a little earlier this morning, but I think those have cleared up. Now, today's presentation is going to deal primarily with Connext tools. Connext tools being those that are used to develop software, debug DDS applications, and the like. Now, why am I presenting this material? Well, I've had customers who've downloaded evaluation software, and they are presented with a suite of capabilities, much of which they are left mostly unaware of. And I want this webinar or this presentation to at least draw attention to the capabilities of at least the Connext tool suite. You'll see what we offer customers and how we can make development go much smoother, much more efficiently, and hopefully accelerate the process such that you'll be able to meet schedules that management puts in place. What we'll be taking a look at, this is an interesting slide, the last little bits of the tool suites. RTI offers a tremendous amount of capability with our software. And as you can see on the last slide, or the last little row, enhanced tools, that's the part we'll be discussing. There's a lot of other stuff that comes along with the kit, but we'll be focused on the tools only. And I've added to the bottom of that list Wireshark, which is a third-party tool, Monitor, which is a monitoring tool. We'll talk about that later. And something very simple, a Pro Terminal. So there are going to be 9 tools that we'll look at in total. And hopefully this will make sense at the end of the presentation. I'm going to start with Shapes. Shapes is a demo that we simply provide customers with. You can get your DDS hat on and start playing with Shapes almost out of the box. You fire up this application. You can publish Shapes, topics, instances, and you can subscribe to these instances on a secondary instance of the application. You can use this application to test the tools that I'm about to go through. So this is our primary demo, and you can use this just to become familiar with DDS. Let's launch into the tools now. Building solutions. There are basically 3 tools here that can be used in terms of building and executing applications. I've got a System Administrator, and I'll show that up here. System Administrator is a web-based tool that, once fired up, provides you with sort of a very intuitive GUI interface. It is responsible, or can be responsible, for generating IDL data definitions, and I'll talk about that, QoS files, the configuration file that you'll need, and it also assists in XML app creation, and I'll talk about that. That's a feature that a lot of people are just not familiar with. Systems Designer can help with that. Then we have the RTI code generator, that generates your source code, which you will modify. And then we have Pro Terminal, which sets up environmental variables such that you can execute your application. So we'll talk about those three tools in a little more detail now. System Designer, data model entering. This is the first step when you're designing a DDS application. You have to create a data model suitable for your application. System Designer gives you an intuitive GUI sort of interface. You would select the data type as shown on the left-hand side of the screen. And on the right-hand side of the screen, you're going to see data types that you can add. So you can create a structure. You can add various data types. You can nest structures. And you can develop your data model very, very intuitively. And you don't have to worry about the syntax of what's coming next. Typically, the data model is accepted in IDL or XML format into the code generator, but you can use this sort of interface to create your data model. This is an XML presentation, and the XML or the IDL presentation, I'm sorry, and the IDL presentation is simply identified when you select the tab on the screen, and you're going to see structured data, XML data, and IDL data. I've simply, when I was doing this, selected IDL data, and that's what it looks like. So if you enter your information System Designer intuitively, you can get this IDL data format created for you, and it will be stored in an XML file for you to use. Okay, on to the next capability of the tool. QoS definition, quality of service definition. Again, it's an XML file. Works in pretty much the same way. You define, as you can see, QoS is defined in orange at the very top of the screen on the left-hand side. And you can simply add libraries. You can add various components such as profiles, various profiles that you could use. You can specify the type of quality of service for a profile in that side of the screen. On the right-hand side of the screen, when you select a type of profile or topic, in this case, topic quality of service, you're going to see a different screen presented to you with all of the parameters associated with a topic quality of service. All the parameters are there. You just have to fill them out if you wish to use them. In doing so, you don't have to know the syntax. You don't have to put the XML file together. None of that. It's done for you, and it comes up like this. The XML file is created for you and is ready to use through this tool. It just makes creating these files a lot easier without any syntactical problems. It's just a little more intuitive, makes life a little easier. XML app creation. Now, this is an interesting feature that is offered by RTI. It allows you to define a DDS application in an XML file. The XML file is labeled user QoS profiles because that QoS profile will be pulled into the application once the application gets started. We provide you with a sample application that you can use for this purpose. It's called Hello World XML Dynamic. It gets compiled and linked pretty much the same way as you would do any application. The difference here is that you're using an XML file that will define the entire system. So in doing that, the file gets defined in System Designer in the following way. You would define your data types, pretty much an IDL file, as we've discussed earlier before. QoS parameters, defined as you have done, as I've shown you just before, using System Designer. The difference here is that you now can define domains. There's a domain tab, as you can see on the left-hand side of the screen. If you hit types, pick out the domain tab, and you can define the domain number that you want this application to run on, as well as the topic name. And then you would select Participant tab and define the publisher or subscriber and writer. And when you do that, you are going to get a list of capabilities that the publisher and writer can have. And you would fill those out in System Designer very intuitively, and it's very simple. That XML file then gets created, and you're going to see at the top of the screen, it'll say Project User QoS Profiles. That file will be created with data types, quas, domain, participant information, and be used by your application. Application fires up, and there's your DDS application running for you. So that's what System Designer offers, an intuitive way of designing data sets and data types, quas files, and the like. It makes it easy. Okay, moving ahead at light speed. The next tool is Code Generator. I think most people should be familiar with this tool. This takes an IDL file and creates source code. A couple of things that you have to do. The IDL file has to be in existence, and you would point to that IDL file with this tool in the upper line. Select it from a menu of possibilities in a directory structure and select the IDL file you want. Additionally, get rid of that. Additionally, you can, oh goodness, let's see, where am I? Okay, additionally, you can also specify the programming language that you can use. And we offer a number of different programming languages. I've selected C here, but you can have C++, C#. In Connext 7.x, which is coming out in Q2 of next year, there are versions available now that you can use, but we support Python natively. So you'd select the language that you want. In addition to that, you would select the development or the IDE system, the system that you're going to use to build. And you're ready to go. Once you've selected all those things, you're able to build the application simply by hitting run, and you'll end up with source code files, which you inevitably have to modify and get ready in terms of if you're reading a sensor bank, you would populate a data structure with those new sensor values in real time and send the data out. So there is some level of modification on the source that you'd have to do prior to compilation. ProTerminal, next tool. This is a very simple one. This simply sets up the environmental variables necessary within a terminal window. The trick here is that when you use this tool to set up a terminal window, you would set up the working directory as the directory that contains the quality of service profile that you wish to use. That's the directory you would specify, because that quality of service profile file will be pulled into your application. Once you do that, you can hit run. It'll pull up a terminal window, and within that terminal window, you would specify the executable that you want to run. And in this case, I've got objects, which is where the executable will reside, the platform subdirectory, and then the executable file that I want to run. And in executing that, you can see that the application comes up and starts writing out. It's publishing information at that point. So this simply just allows you to run an application very, very quickly. As a note, I had a customer that I'd been working with. They needed assistance in developing an application. I was able to get their IDL file, their quality of service information, and be able to build an application within 20 minutes and having it run on my system using these sorts of tools. Once you get your application running now, it becomes a time to take a look at issues that may crop up. We have 4 tools that allow you to do this. Admin Console is sort of one of the flagship test tools that RTI offers. It's proprietary to RTI and allows you to debug DDS systems very quickly and efficiently. If Admin Console is not working, or you can't get a DDS connection up, let's say across a subnet, or you're hitting a firewall, you can try DDS Ping and DDS Spy as tools to establish connectivity. And if you can't get that working, then you can jump down to Wireshark, which is a protocol analyzer. So let's take a look at those tools, and I'll spend a lot of time on Admin Console because it's exceptionally powerful in terms of debugging. So if you have network issues, firewalls and subnets, you're not going to be able to get discovery to occur, have nodes appear within the DDS system. You can use Admin Console to look at that, as are the other tools. Routing service status. Many times customers, if they're using routing service, which is something that bridges domains, if you're going from domain 0 to domain 1, routing service is the tool you want to have in place. Many customers use the default settings for routing service, throw it into a system, and it does work because everything is wildcarded. It'll pass anything for the most part through its service. However, it should really be configured, and sometimes it's not configured correctly. Admin console can try and highlight issues with regard to routing service. Secure networks can be debugged, and quality of mismatches, data mismatches can be highlighted with admin console. So take a look at how admin console sort of works. In general, it will show a DDS network topology, and I'm showing a screenshot of admin console here. And there are a number of items here I can show, and I don't want to go through this tool and show you every little feature. You can read the manual to figure that out. What I want to do is simply show capability. So in this case, I'm showing network topology. I've got 3 nodes working on one machine in the center of the screen, so you'll get a graphical display. Admin console exposes quality of service issues. If there are incompatibilities, they're identified very quickly with this tool. You can subscribe to a particular topic and show that topic in tabular form or in real-time graphical form. Very useful in verifying, making sure your data is correct. You can, in Connext 7.x, publish data using this tool, assisting in testing systems. And in addition to that, this tool will also provide you with warnings and errors that are provided by logging tools that are associated with our application. So there's a tremendous amount of information that this tool can provide you with. So we'll start with the basic system view. There are a few things to note here. The system view will show you just about everything. It can get rather congested at times if you have an awful lot of nodes. You can eliminate the congestion, as you'll see a little bit later. But the bottom line is, because everything is shown, problems can be identified quickly. I know it's a little hard, maybe hard to see, but you'll see a little red dot associated with a particular machine. And you'll see little red dots associated potentially with processes, the Shapes demo application. That red indicator, it alerts you to a potential issue with that particular application. So you can see almost immediately that through a system view, there are going to be issues or can be issues in your system. Red indicates an error condition. Yellow indicates a partial error condition, which means that you can have potentially one writer, multiple readers, and one reader may be receiving all topic information, but a second reader may not be. That's a yellow condition because it is partially working. Moving on, if you do have an issue, you can drill down into that issue very, very quickly by selecting an entity. Now, an entity within DDS lingo can be a topic, it can be a publisher, a reader, a writer, a participant, even the machine itself, the node. You can select a particular entity. In this case, I've selected the process on the right-hand side, left-hand side, and you can see that little red dot, and that'll bring up an entity info screen, and it'll be presented to you with information on health. And you can see that, oh, there's an issue with requested and offer quality of service. Well, you're aware that the quality of service may be at fault, but you really, at this point, do not know why. And you can drill down even further by selecting the particular fault itself. And by selecting that screen, you can click on that particular entity, the data reader, and you'll get an identified issue. It'll come down and it'll provide you with a different view of the screen, focusing only on that particular issue. And you can take a look at what's going on at that point. At the top of the admin console, there are a number of items you can select to give you various views and various screens. And I'll take you through those views in a minute. But one of these views is called Match Analysis, and you can take a look at what's going on. When you select an entity and select Match Analysis, the issue is identified immediately. In this case, the issue identified is reliability is mismatched or incompatible. I'm offering from the publisher, best effort reliability, whereas on the subscriber, I've selected reliable reliability. It's expecting a reliable link, not getting it. This is flagged within the match analysis screen. And the takeaway here is you're very quickly able to understand what's going on in your system and debug it quickly simply by clicking on the red little graphical tabs on the window and then going to the appropriate screens to collect information associated with that sort of an issue. Data mismatches are also flagged. I was able to create an error scenario where a topic, the topic name was assigned to two different data types. And Admin Console was able to identify those data mismatches and bring that up in my match analysis screen. So you're able to use Admin Console to find data mismatches. So you're saying, why would that affect my development effort? In many instances, development teams are distributed, and it's not uncommon for development teams to tweak a quality of service file or maybe rebuild a data type. We've seen this many times, and they go out into a deployed system, implement what they think is a fix, only to find that the system is behaving poorly. Admin Console can find problems very quickly and alert you to them. So that's the takeaway. Basically, that's what Admin Console does. There are additional views that are provided by Admin Console. As I'd mentioned earlier, the system screen can become somewhat congested. You can select other views that will reduce the scope to which Admin Console will display entities. In this case, I'm simply selecting a single domain, and I can see everything connected to that domain. I can also select specific topics as well, and it will reduce the display with regard to only those topics that are communicating on the data bus. So you can restrict the amount of information being presented to you when it does become overwhelming. You can get a quality of service view. Now, if you select an entity, typically data reader or writer, or you can select maybe a publisher or a subscriber. It depends on the entity you select, but you can get a quality of service view on that entity, which will identify all quality of service settings associated with that entity. This could be very helpful if you're trying to understand, let's say, what a quality of service file may look like from a node or a device that you've not been working on. Logs. This is interesting. Logs can be shown. Now, logs is it's a collection in tabular form of activities that have happened on the data bus. The log will tell you, let's say, when a participant has joined the data bus, when a particular topic has been created and at what time. So it's a running tabular screen of activities happening on the data bus, nodes coming and going, incompatible QoS in particular. And you can take a look at the data log to just simply note activity or identify problems on the data bus. For instance, I've got samples are lost for a circle. So you can see what's going on using logs. Okay, next. Processes. This is an interesting screen. It simply just alerts you to the processes that are running, the applications that are running on your DDS bus, and provides you with health information. Is it a healthy node, or are there warnings associated with it? These warnings are generated by logging activity coming off of the application itself, and they give you additional information as to what may be happening with that particular device. Okay, it may not be critical, but it is informative. Another set of views, a health view, I'll go through quickly. Again, warnings are shown a little bit differently, and you can take a look at what you could expect for a warning. Again, not critical, but in this particular case, it'll say reader-only topic. What does that mean? Well, it means that you have a node that is trying to read a topic, but there are no publishers or writers out there issuing that topic. So in this particular case, this node is a reader only, and is trying to accept data, but nobody is really sending it data. And why is that? Well, because the cost doesn't match. And because the cost doesn't match, it's a reliability issue. It's not receiving information. So you get additional information through those warnings in this health screen. Data type view is an interesting view in that it shows you what the data type actually looks like. It gives you that almost, it's the interpretation of the IDL definition. And you can take a look at what the data type actually looks like. If you have a data type mismatch, this would be very useful. You can see what the incoming data type looks like, and then maybe accommodate it by changing your IDL data definition. Secure systems. Now, RTI offers a secure module, comes with keys and signed documents and signed governance documents and permissions and these sorts of things. When you have a secure system up and operational, there's a lot of encryption or can be used. You can't really get into the system, but Admin Console can. Admin Console allows you to get into a secure system by having pointing to the actual files that are on the system that supports security, the encryption files, the keys, and these sorts of things. So secure systems can be interrogated with Admin Console. Simply use secure artifacts within the preferences screen. Cloud communication is also supported by the Admin Console. RTI offers something called a real-time WAN product. It comes in a Connext Anywhere suite of products. It includes secure. But what this allows you to do, for those that are unfamiliar with the tool, allows you to go and communicate through the cloud using UDP, and it's an exceptionally efficient way of communicating. In terms of trying to debug capabilities through the cloud, Admin Console allows you at least partial view into the cloud to take a look at the entities that we may have inside of the cloud, like routing service, which bridges things, cloud discovery, these sorts of things. And you can set up Admin Console to have a view into the cloud such that you can debug certain services that are running inside of the cloud. So Admin Console is exceptionally powerful. The takeaway really is that it quickly identifies quality of service, data mismatches, and things of that nature. Now, there are a few interesting other things that Admin Console can do in this debug routing service. As I'd mentioned before, in System Designer, you can use System Designer to develop QoS files and things of that nature. QoS files are used by routing service to route traffic from one domain to another, as I've shown here. However, there are times when routing service isn't working properly. And what you can do is use Admin Console to take a look at routing service, and you can select routing service as an entity in one of the screens of the physical view screen, and you will get statistics. And I'll show you the graphic. It's better in a graphic. You can get both the tabular form graphic of statistics with regard to the routing service, which will give you samples passing through routing service per second. It will give you data rates passing through routing service per second. And importantly, it'll give you a latency as to how long a packet takes to pass through routing service. So you'll get statistical information if routing service is working well, and you will also be able to identify if routing service is not working at all. In addition to that, you can control routing service remotely using Admin Console, and it has capabilities of turning routing service on and off, this sort of thing. So you can use Admin Console to take a look at routing service. And finally, Admin Console can allow you to take a look at the data being sent from node A to node B, verify that it's correct. Could be used for data verification, calibrating instrumentation, or simply self-test prior to going into deployment. So in terms of displaying information, there are a number of different views that can be displayed. I'm not showing you how to set this up. Typically, you would have to subscribe to a topic prior to using this. And there are sets of screens. If you want to take a look at the data, it will ask you, do you want to subscribe to a topic? You will answer yes. And away you go. You'll get various screens showing the topic. At the top, I have the topic triangle. And if you take a look at the screen, you're going to see three instances, green, red, and yellow on the right-hand side of the screen. And those instances will be displayed tabular format. And the content of those instances, the actual data, will be displayed in real time as it arrives into Admin Console. These numbers will be scrolling. In our example, if you're using shapes to test this out, scrolling at 16 samples per second, kind of hard to read and understand what's going on. Nonetheless, it's there for you to see. On the left-hand side of the screen, you can take a look at Sample Inspector, and by clicking on a particular instance, you can view the content of that instance only. Same gig, it's tabular form. The data values are going to be scrolling in real time at the rate at which those samples are presented. That may not necessarily be the most useful way of being able to decipher your information, so we have other views that you can use. Sample logs, same gig, tabular form, except the sample is kept in memory. Typically, we can keep up, I think, to 1 million samples by default. You can set that. These samples are stored in memory. The actual instance is identified along with the topic, and the content of the data type is also stored. And you can scroll through this table and take a look at data if you wish to do so. Again, that's a little hard, but you can do that. A better way would be to graphically represent the information. And you can do so simply by picking up real-time time chart in the menu structure of Admin Console and have that displayed for you. And you can see here, I'm using shapes again as demo software, and I'm showing the X value. The X value increases and then decreases because the shape is moving across the screen. Anomalies in data will be shown in the screen pretty quickly. If for some reason there's a data that drops out to 0 because of one reason, you should be able to see this quickly. You can let this run for a while, up to 1 million samples or as many samples as you wish, and you can interrogate graphically the screen to see if there are problems with your data flow. So Admin Console provides you with that view of data such that you can identify issues. In Connext 7.x, we allow you to publish topics using a Python script, and you can push that out to the data bus. You can create your own topics as well using Admin Console. And again, you just have to write the Python script, let it run. Python, the values generated using the script can be stored into cache, or they can be sent out to the data bus in real time if you wish to do so. You can run the cache later on, and you can dictate the rate at which that data is presented to the data bus as well. So you'll have tremendous capability with Connext.7 simply by being able to publish topics out to the data bus that may or may not exist. Useful in testing applications. Okay, we're into the final stretch. I've got a few minutes left. DDS ping, the following tools are typically used to take a look at connectivity between nodes and devices. And, typically you're going to find if you're jumping subnets, maybe multicast isn't working, or if you're trying to get through a firewall, it's just not working. It's because discovery is not able to complete. Messages are not able to flow between nodes. DDS ping is a tool that you can run to, I guess, uncover connectivity issues. Basically, it sends a ping topic from one machine to another. That means you're going through discovery and endpoint discovery, and allow that ping topic to make it from one machine to another. You can set up various transports, and you can set up a peers list using this tool. The GUI, looks something like this, where when you fire up the tool, you can set various parameters like domain IDs and such. You can set up the actual topic. We use a ping topic. You can send any topic if you have one. Use the default QoS file, but you can set this up. And the takeaway here is if you're trying to jump a subnet, you can set up a peers list and identify different IP addresses that you want to communicate with. If there is that issue. If this simply doesn't work, you may have a firewall issue, and you can go back and either assign ports in the firewall to allow traffic to pass through a port, or just disable the firewall initially to make sure that it is a firewall issue. You can also specify transports. In this case, I'm specifying UDP v4 because we're trying to make it through an IPNet. DDS Spy is a different tool. It allows you to send topic information from your application to the DDS Spy application. DDS Spy is a tool that simply goes through the discovery process with your application to make sure it's going to work. Spy will show you all topics, and it can be set up pretty much the same way as ping was set up. You set the domain partitions. You can filter out topics if they're coming in too quickly. But basically what it will do is simply display the incoming topic. When you fire up the tool, gives you a little bit of discovery traffic at the top because it will accept that. And then it will print out the actual topic content. In Connext 7.0, the formatting of the display is a little more intuitive than what I'm showing here. It'll give you data. It'll give you a lot of different information in a more pleasing format. When all else fails, Wireshark is the tool that you can go to, third-party tool. There's an RTPS. It's the underlying protocol of DDS. RTPS allows you to take a look at data packet content in an intelligent way. What Wireshark does is display information, gives you the origination IP address, the destination IP address, the packet type, deciphered packet content because of the RTPS filtering capability, and raw packet content. It's a tool that allows you to see if you have communications from point A to point B, what the packet actually looks like. Are you getting discovery packets through the system? Are you getting data packets through the system? A very low-level tool that gives you raw data flow. If you do not see your nodes or your IP addresses on this tool, then you know you may have a firewall issue or the application is dead. So Wireshark is a go-to tool for debugging issues that are very difficult to find. Performance, 2 more tools, and then we're done. Perf test. I'm not sure if a lot of people are familiar with this tool. Perf test can do one of 2 things. It can provide you with performance statistics of your network prior to you even implementing or deploying DDS. Perf test gives you a view of latency, how long it takes a packet to make it from one end of the network to the other, as well as gives you data throughput statistics. So you can understand or get a view as to what's happening. Why is this important? Many networks have routers in them. They may be configured improperly. Maybe the packet sizes or configuration allows for fragmentation. When you have large amounts of fragmentation, you have a possibility of packet dropping. When you have packet drops, you can't reconstitute the packet. Problems. This tool gives you a view of performance on your network, data throughput and latency. Can do so for raw UDP, and it can do so for DDS traffic as well. If you're running DDS traffic, you can set the number of publishers that you want and the number of subscribers with this tool. You can set packet size. You can set some quality of service issues like batching. So you have a tremendous amount of flexibility to have this tool mimic your application and provide you with performance information. Now, with that responsibility, you've got to really understand what you're doing with this tool. And there can be certain things that you've got to be cognizant of. The tool gives you, let's say, lousy performance information. And you say, well, gee, DDS isn't going to work on this network. And that's not really the case. You have to understand what's going on your network. As I've said, routers can fragment packets and they'll be dropped. Is your device, your actual device, prioritized to handle communications? IP stack has to be prioritized accordingly. Are your buffer sizes correct? Timer resolutions, especially with RTOSs, have to be in place so that you can get actual true results from perf tests, because if resolution is not high enough, you will not be catching all packets. So there's issues that you have to be very aware of when using this tool to understand what's going on. Last tool I want to talk about is Monitor. Now, Monitor is a tool that sits on your network, and it attaches to applications that will push monitoring information out. So your application has to be defined using an XML config file, and that application will be enabled to put out monitoring-based information. And Monitor will give you, as shown here, received packet counts, dropped packets, rejected count. It gives you statistics as to what's going on between your application and the DDS network. It's used typically to tune a network if there are problem areas where traffic is impeded in some form. This tool can bring those to light. This tool will connect to all applications that have been configured to communicate with this tool, and you would select the application on the left-hand side of the tool, the application that you want to actually view. Tremendous amount of information being presented to the monitor, and you can take a look, fine-tune your DDS application using Monitor. And the last but not least, I'm just going to make mention of something coming out in 7.3 LTS. It's a tool called observability. And what's observability? It's a tool that's going to collect, well, not the entire monitor package, but a subset of monitor statistics from all applications on the DDS bus. Those monitor packets will be aggregated, sent into a number of different databases. We currently use Grafana and Prometheus for logs and metrics, and then we use Grafana to provide you with a dashboard, a web-based dashboard, and you can take a look at an entire DDS system and identify hot spots, problems, issues in your entire system. I would say it's very close to real time. It can surface issues very quickly, and it is based upon Monitor. This will be out in Q2 of next year. And with that, I'll just move over to Q&A. I know it's been a marathon session. I know I've gone very quickly, but my intent was simply to draw awareness to the tools that RTI provides.
Fantastic. Thank you, Brian. Let's go to answer questions that we're receiving in the chat. And I'm going to read the first one that says, it appears that the tools can identify quality of service file incompatibilities between nodes. Can you also detect the quality of service parameter violations?
Yeah, admin console gets the discovery propagated quality of service settings, and it does an analysis on those to look for inconsistencies. Like you might say, I want this writer to be best effort, but I want the reader to be reliable. Well, DDS doesn't know what to do, right? It can't have it that way. Those two aren't going to, communicate. So admin console does an analysis of that and displays the results that Brian was showing earlier. One interesting thing is that Monitor actually has instrumentation in the monitoring library. So you'll get the same information out of Monitor UI, but it'll be instrumented rather than through analysis. So a little bit different, but both tools will end up showing you the same information.
Perfect. And let's go with the second one that says, once started, does the admin console dynamically detect new nodes joining and those that leave?
Yes, absolutely. So we use DDS Discovery. In fact, Admin Console is just another DDS application. Everything that we've done with this product could be done by anybody using the APIs. There's no real magic special sauce or anything. We've just packaged it all together and implemented all the different views. So when things come and go, DDS Discovery lets us know when they come and go, and things will in real time pop up into the UI, and they'll go away as the network is changing. Yeah.
Perfect. And I think we have some more 1 minute more for questions. A question more. Does the admin console show all quality of service values associated with the chosen entity?
No, it doesn't. So Admin Console only has access to the discovery propagated information, which is a subset of the total quality of service. There are a few hundred quality of service settings. If you do need all of them and you need access to them remotely, you can use Monitor UI today to do that. Monitor UI, like I said, doesn't require an instrumentation package, which we ship with the product. You have to enable that, and then the UI will get the full quality of service from all the running entities in the system. So, if you're deploying a large system, that's something to keep in mind, because it will use a lot of bandwidth to download all that information when you start the UI. But you can use Monitor UI for that use case today. Admin Console just shows you the ones that it finds in Discovery. Yeah.
Fantastic. So yeah, I think we are over time, 2 minutes over time. So thank you so much, Brian, for your presentation, and Ken for answering the questions the audience sent. Those questions that we couldn't answer, we will follow up via email. And just a reminder that this webinar will be available on demand through the same registration link. Thank you to our audience for joining us, and have a great day.
Thanks, everybody.